NENOMATICA, where mathematics meets YouTube excellence. The addition and subtraction of powers. Welcome! Today we'll solve a complex algebraic expression involving powers and exponential terms. Let's break this down step by step. Let's start by rewriting the expression to see some patterns. First, note that 25 equals 5 squared, so we can rewrite 25 to the power of 35 as 5 to the power of 2, all to the power of 35. Also, 0.04 equals 4 divided by 100, which equals 4 over 100. This can be rewritten as 4 over 100 to the power of 17, and 125 equals 5 cubed, so we can rewrite 125 to the power of 11 as 5 cubed to the power of 11. Now, let's apply the power of a power rule. 5 squared to the power of 35 becomes 5 to the power of 2 times 35, which is 5 to the power of 70. So let's simplify the numerator. We have 7 times 5 to the power of 70, plus 13 times 5 to the power of 70, minus 2 times 5 to the power of 70, minus 8 times 5 to the power of 70. We can factor out 5 to the power of 70 from the numerator. This gives us 5 to the power of 70 times the quantity 7 plus 13 minus 2 minus 8. Let's simplify the expression inside the parentheses. 7 plus 13 equals 20. 20 minus 2 equals 18. And 18 minus 8 equals 10. Now, let's combine the exponents in the denominator. We have 5 to the power of negative 34 times 5 to the power of 33. Using the product rule for exponents, when we multiply powers with the same base, we add the exponents. So we get 5 to the power of negative 34 plus 33, which is 5 to the power of negative 1. Let's simplify the remaining expression. In the numerator, we have 5 to the power of 70 times 10. In the denominator, we have 2 times 5 to the power of negative 1. First, let's divide 10 by 2 to get 5. So we have 5 to the power of 70 times 5, divided by 5 to the power of negative 1. Using the division property of exponents, we can rewrite this as 5 to the power of 70 times 5 to the power of 1, since 1 over 5 to the negative 1 equals 5 to the power of 1. Finally, which is 5 to the power of 72. Let's look at the given expression and solve it systematically. Here's our expression. We need to find the value of 2 to the power of 3 minus 2 to the power of 3 times the square bracket containing 3 squared minus 3 squared times the bracket 2 to the power of 3 minus 3 squared to the power of negative 1 to the power of negative 1. We know from the given information that this expression equals 68 over 9. Let's start by evaluating the basic powers in our expression. 2 to the power of 3 equals 8, and 3 squared equals 9. Now let's evaluate 8 minus 9 inside the innermost bracket. This gives us negative 1. Next, we find negative 1 to the power of negative 1. When we raise a number to the power of negative 1, we're finding its reciprocal. So negative 1 to the power of negative 1 equals negative 1. Now, let's multiply 9 by negative 1. This gives us negative 9. Next, we calculate 9 minus negative 9. Subtracting a negative number is the same as adding its positive value. So we get 9 plus 9, which equals 18. Now, we apply the negative power rule again. 18 to the power of negative 1 equals 1 over 18. Next, we multiply 8 by 1 over 18. This gives us 8 over 18, which simplifies to 4 over 9. To subtract these terms, we need a common denominator. Let's convert 8 to a fraction with denominator 9. 8 equals 72 over 9. Finally, we subtract 4 over 9 from 72 over 9. This gives us 68 over 9. We need to verify that the expression equals 3 raised to the 28th power. Let's start by simplifying the numerator. In the numerator, we see 9 to the 7th power plus 9 to the 7th power. This is twice 9 to the 7th power, or 2 times 9 to the 7th power. Now, let's work on the denominator. We can write 54 as 27 times 2, and 1 over 3 raised to the 7th power is the same as 3 raised to negative 1, all raised to the 7th power. Next, since 9 equals 3 squared, 9 to the 7th power equals 3 squared, all raised to the 7th power. By the power rule, this equals 3 raised to 2 times 7, which is 3 raised to the 14th power. Let's simplify further. Using the power rule, 3 squared to the 7th power equals 3 raised to 14. So our numerator has 2 times 3 raised to 14 times 3 raised to 10. Using the product rule for exponents, 3 to the 14th times 3 to the 10th equals 3 to the 24th. So our numerator becomes 2 times 3 raised to 24. Now, the denominator has simplified to 3 to the negative 4 times 2. We can now cancel the factor of 2 in the numerator and denominator. When dividing powers with the same base, we subtract the exponents. So this equals 3 raised to 24 minus negative 4, which is 3 raised to 28. Welcome to our math video. Today we're going to solve an interesting problem involving powers and divisibility. Let's look at our example. We need to find two numbers between 7 to the power of 501 and 49 to the power of 250 that are divisible by 3. Let's begin by understanding what we're working with. We'll first express these numbers in a way that helps us compare them. 7 to the power of 500, and 1 can be written as 7 to the power of 1 times 7 to the power of 500. This equals 7 times 7 to the power of 500. Similarly, 49 to the power of 250 can be rewritten as 7 squared to the power of 250. Using the power rule, this equals 7 to the power of 500. Let me highlight an important rule we just used. When we have a power raised to another power, we multiply the exponents. So, in our case, 7 squared raised to the 250th power equals 7 raised to the power of 2 times 250, which is 7 to the power of 500. Now, let's establish what we're looking for. We need to find numbers between 7 to the power of 501 and 49 to the power of 250. Looking at our simplified expressions, we can rewrite this as finding numbers between 7 times 7 to the power of 500 and 7 to the power of 500. So we need numbers between 7 to the power of 500 and 7 times 7 to the power of 500. What numbers could be between these two values? One approach is to look at multiples of 7 to the power of 500. We could consider values like 3 times 7 to the power of 500 or 6 times 7 to the power of 500. Let's check if these fall in our range. We know that 7 to the power of 500 is less than 3 times 7 to the power of 500, which is less than 6 times 7 to the power of 500. 7 to the power of 500, which is less than 7 times 7 to the power of 500. Now, we need to check which of these are divisible by 3. For 3 times 7 to the power of 500, it's clearly divisible by 3 because 3 is a factor. Similarly, 6 times 7 to the power of 500 is also divisible by 3 because 6 is divisible by 3. Therefore, we have found two numbers between 7 to the power of 501 and 49 to the power of 250 that are divisible by 3. Welcome to our mathematics video. Today, we'll solve an interesting problem involving divisibility of the difference between two large numbers. Here's our example. Can we say that the difference between 7 to the power of 501 and 49 to the power of 250 is divisible by 6? Let's start by rewriting 49 as 7 squared. This will allow us to work with the same base. Now we can apply the power rule for exponents. When we raise a power to another power, we multiply the exponents. So 7 squared raised to the power of 250 equals 7 to the power of 2 times 250. Let's calculate 2 times 250, which equals 500. Now we can factorize the expression. We can rewrite 7 to the power of 501 as 7 to the power of 500 times 7 to the power of 1. We can factor out the common term 7 to the power of 500. Now we can simplify 7 minus 1, which equals 6. Welcome to our math video about divisibility properties of powers. Today, we'll explore an interesting problem involving powers of 7 and show how to prove that their sum is divisible by certain numbers. Let's dive into the problem we need to solve. Here's our example. We need to show that the sum of 7 to the power of 500 and 1 plus 7 to the power of 500 is divisible by the numbers 2, 4, 7, and 8. Let's write this out mathematically as 7 to the power of 500 and 1 plus 7 to the power of 500. To solve this problem, we'll use a key property of exponents that will help us simplify this expression. Let's recall a useful rule. For any number, we know that a to the power of n plus a to the power of n minus 1 equals a to the power of n minus 1 times a plus 1. This rule is useful because it allows us to factor out the common exponent term, which often leads to a simpler expression that makes divisibility easier to check. Now, let's apply this property to our problem. We'll start by looking at the original sum, 7 to the power of 500 and 1 plus 7 to the power of 500. First, let's rewrite 7 to the power of 501. This can be expressed as 7 to the power of 1 times 7 to the power of 500. Now, let's factor out the common term 7 to the power of 500 from both parts of the expression. So, we get 7 to the power of 500 multiplied by the expression inside the parentheses, which is 7 plus 1. Let's simplify the expression inside the parentheses. 7 plus 1 equals 8. So our expression becomes 8 times 7 to the power of 500. Now, let's check if this expression is divisible by each of the numbers we need to check: 2, 4, 7, and 8. First, is this expression divisible by 2? Yes, because 8 is divisible by 2. Is it divisible by 4? Yes, because 8 is divisible by 2. Is it divisible by 4? Yes, because 8 is divisible by 4. Is it divisible by 7? Yes, because 7 to the power of 500 contains 7 as a factor. Is it divisible by 8? Yes, because 8 is directly a factor in our expression. Therefore, we've proven that the sum 7 to the power of 500 and 1 plus 7 to the power of 500 is divisible by 2, 4, 7, and 8. This is our final answer. The expression 8 times 7 to the power of 500 is divisible by all of the numbers we needed to check. The key technique we used was factoring out the common power term, which simplified our expression and made it easier to check divisibility. To summarize, we approached this problem by, first, recognizing we could apply the exponent property to rewrite the expression. Second, factoring out the common power of 7 to the power of 500. Third, simplifying to get 8 times 7 to the power 7 to the power of 500. Third, simplifying to get 8 times 7 to the power of 500. And finally, checking that this expression is divisible by all required numbers. Remember, when working with sums of powers, looking for common factors is often the key to solving divisibility problems efficiently. Welcome! In this video, we'll solve a problem involving powers and find the result in standard form. Let's look at our example. If a equals 9 to the power of 25 and b equals 27 to the power of 16, we need to find the value of 6a cubed divided by a plus 9b. Let's start by substituting the given values of a and b into our expression. Now, we'll apply the power rule to simplify the expressions. When we have a power raised to another power, we multiply the exponents. So 9 to the power of 25 cubed becomes 9 to the power of 75. Next, let's rewrite 27 to the power of 16. Since 27 equals 3 cubed, we can rewrite this as 3 cubed to the power of 16. Again, applying our power rule, 3 cubed to the power of 16 becomes 3 to the power of 3 times 16, which is 3 to the power of 48. Now, let's express all terms with the same base. We can rewrite 9 as 3 squared. Applying the power rule again, 3 squared to the power of 75 becomes 3 to the power of 2 times 75, which is 3 to the power of 150. Similarly, 3 squared to the power of 25 becomes 3 to the power of 50. Let's simplify further. In the denominator, we have 3 to the power of 50 plus 9 times 3 to the power of 48. We can factor out 3 to the power of 48, giving us 3 to the power of 48 times 3 squared plus 9. 3 squared is 9, so the expression in parentheses becomes 9 plus 9, which is 18. We can further simplify the denominator by expressing 18 as 2 times 9, which is 2 times 3 squared. Now, we can simplify the fraction. 6 divided by 2 equals 3. And we subtract the exponents when dividing powers with the same base. 3 to the power of 150 divided by 3 to the power of 50 gives us 3 to the power of 100. So, our final answer is 3 to the power of 101. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.